All right. Good morning, good afternoon, good evening. Welcome back, or welcome if you're just joining us here in the architecture track. My cat has decided to hang out with us here. We'll see how long that lasts. But I'm sure he's actually here to listen to Oleg here talk about functions. I'm very excited about this presentation because everything seems to be as a service these days. I like to joke that I'm an architect as a service. So I'm very excited to see what Oleg is going to talk to us about here with functions and how I love anything where I can just write it once and have it go everywhere. So Oleg, please show us how this is done, my friend.
Very good. How are you, everybody? It is very strange to do it live to a screen without seeing faces, without seeing eyes. We try to connect and be sort of excited and reactive, but I will try to do my best. My name is Oleg Zharkowski. I am currently a project lead for Spring Cloud Function and Spring Cloud Stream, and I'm coming to you live from beautiful south of France. My history with Spring, just very quickly. So I started in 2008. My proudest moment, I was the 99th employee of Spring Source, that little startup that turned into this grand big thing. Worked as an engineer on Spring integration. Then at some point of time, I decided to try my chances with this great new technology called Hadoop that didn't turn out to be what I expected it to be. I came back to my team, and that's where I'm at right now, doing exciting stuff within a Spring Cloud Stream and Spring Cloud Function. I guess at this point of time, I'm going to share the screen, and we'll get on. Share and presentation. All right. So here is the agenda. As I was discussing with some people in the Slack room, I am typically, like, I do have some slides, but most of what's going to be happening today is going to be live code. This presentation is going to be kind of structured in two different parts. So first of all, we're going to talk about, functions, why functions are important, and we're going to really do I say, deepish dive into Spring Cloud Function. Obviously, 55 minutes wouldn't be enough. I mean, 2 hours, 55 minutes wouldn't be enough. But at least I hope to show you some of the cool parts, some of the most interesting parts of Spring Cloud Function. But at least I hope I will show you just enough that you can comfortably navigate the rest on your own. So that's like the first half. And the second half is we're going to get to this run anywhere part that Nate is so excited about. And hopefully, for those of you who have already attended Mark Heckler's presentation and some other presentation, you're starting to almost like see where we're going with that. Because Mark was writing functions, I'm going to be writing functions. And just like Mark, I'm going to show you how you can use function in streaming applications, but also show how you can use the same functions in a variety of different styles of application without ever changing your code. So truly write once and run anywhere. So let's begin. First thing is the scope. So what I'm going to be talking about, and again, I had a much more slides to that would show it for you and do all this like go very little detail. But at this point of time, I cut it down just so I can get you quickly to the juicy parts, to the coding part. And we're going to get to the demo literally after the next slide. But here's the scope. So when I say function, I want to make sure that we clearly know, like, not me, but you clearly know what I'm going to be talking about. And because there's a functional programming style, there's a functional programming development, there's many different things out there that kind of use the word functional. So that's why really I want to make sure that everybody's clear on what we're talking about. And what we're talking about is the Java 8 functions, which is basically the three core strategy presented to us through Java util function package since Java 1.8. So supplier, function, and consumer, and also something that may look like supplier, function, and consumer, kind of a duck typing, which is the Poja function. Okay, so that's really the scope. And what's interesting about this is that you're going to say, okay, well, these three interfaces come from Java, from JDK. So I don't need Spring to write a function. Of course you don't, right? So why would I need Spring? What additional value does Spring, and in particular Spring Cloud Function, provides you with? So, and that's what we're going to do next. So Spring Cloud Function. So this is one slide that was kind of digested from about 6 or 7 slides. So this is just one slide, kind of gives you the whole sort of a bullet point, bam, bam, bam. And now everything that you see here, we kind of going to go into the Eclipse and start writing code and start looking at how it works. So what is Spring Cloud Function? And with that, hopefully, to build the case why just writing function isn't enough, that you need some additional abstractions on top of it to help you really navigate the complexity of typical enterprise environment where you still want to write functions. So Spring Cloud Function helps you promote implementation of business logic via Java functions. It gives you this uniform programming model because you're still going to write Java functions. There is nothing Spring in your functions, right? Everything comes as peripheral, and I'll explain you that in a minute. And what Spring Cloud Function gives you, this additional functionality, gives you this transparent type conversion, which again, Mark had pointed out earlier when he did his streaming talk. Function composition, which is extremely cool feature. Poacher functions, which is already mentioned. Basically, if it looks like a function, then we're going to treat it as a function. Reactive support deployment functionality, which is functions with multiple inputs and multiple outputs, and so on and so forth. And it also gives you the ability to integrate with, provides you with the ability to integrate with a bunch of serverless platforms like Amazon AWS, which I'm going to demonstrate today, Google Cloud Functions, Microsoft Azure, and a few others, right? So again, a lot of these are driven by the community. Like, for example, Google Cloud Functions, or Google reached out to us, and they're pretty much maintaining that portion of Spring Cloud Functions. So very cool, all of them. Okay, and as I promised you, we're going to go straight into the code. So live code, right? So again, live-ish. So I have something just pre-written just for the sake of saving time. We only got 5 minutes. But the rest we're going to evolve as we go along. So what you're looking at right here, and I hope producers will tell me, I'm currently not monitoring the Slack channel, so hopefully other guys do. And producers hopefully will jump in and tell me if my fonts or something, but I believe based on earlier verification that my fonts are okay. And this is really the only thing, like right here, that you want to be able to see, and then the console, obviously. So what we're looking at right now is, as you can see, a plain Spring Boot application with a single function being defined in it, right? So just to show you, there is no additional application properties. There is really, anyway, there's nothing there. And in the POM file, again, a lot of things are commented. So this is really the only dependency that I have. And then obviously the starter dependency, because this project, the initial project, was created using Spring Initializer, which I'm not going to cover today, but I'm kind of hoping that you guys are familiar with. And again, Mark Heckler did a good sort of intro into how to create, and as well as Glenn, how to create application using Spring Initializer. So that's it. We got Spring Function application. So what can I do with this? Well, for those of you who are Spring users, you're going to say, well, okay, so I can get a bean straight from application context. Like, basically, I can say context.get bean, and bean name in this case is going to be uppercase, right? And operate on this function. Of course, you can do that, but it's the same as you just using it raw without any additional behavior. And if you remember, the core message of Spring historically being that you address functional requirements, will take care of the boilerplate. So there's a lot of the boilerplate code that you need to start worrying about. You may not see it right away, but eventually it'll come to you. And using it as a raw function, that would imply that you're gonna you're gonna have to worry about this boilerplate stuff like type conversion, composition, and everything else on your own. And then you're going to say, we'll get to that. So what we have instead, you want to be able to retrieve this function. And again, this is the portion of the presentation where we're going to deep dive into Spring Cloud function sort of functionality, like what Spring Cloud function does. And then we're going to get into the write once, run anywhere. So I'm going to kind of rush up a little bit. So what we have, one of the core abstractions within Spring Cloud function is the function catalog. And function catalog sort of acts as kind of a highly specialized bean factory for functions, right? So what we're going to do is going to say function catalog, catalog, and then get it from the context, get bean. Now, this code that I'm writing right now, most likely you will never have to write. As a user of Spring Cloud Stream, or as a user of REST, as a user of RSocket or whatever, you would never have to write this code. You would never have to write code that directly interacts with function catalog, right? However, as an integrator, if you try to integrate something with Spring Cloud function, like we do, for example, like the most recent one was RSocket, which I'm going to be talking about with Spencer tomorrow, right? But if you're an integrator, these are the bits that are important to understand. So function catalog is the core abstraction. And as I said, it's like a specialized bean factory for functions, right? And here we're going to basically say, get bean, function catalog, function catalog.class. And now, from catalog, we can actually do a lookup on a function. And this is where things become very important, right? Because, so I can get a function. Let's just skip the type configuration, say function equals function catalog, and obviously uppercase have to be a string. So we basically got function by name, and now we can say function dot apply, nope, not and then, apply, and we're going to say hello Spring One, right? And actually, let's print it out. Okay, so let's run it quickly. And we got ourselves uppercase hello Spring One. So whoop-de-doo, right? You could have done it easily by just simply getting it from a bean factory. Okay, fair enough. But what if let's start getting into some of the juicy pieces, even though this doesn't make any sense, right? But remember, I'm passing an integer here, but this is a string, right? Obviously, there's no true uppercasing of a 23, but it still represented it properly. It still didn't fail. It still managed to understand that, oh, I can convert integer to string. And this is really not even Spring Cloud function functionality. We rely on the core Spring Boot abstractions, the core Spring Core abstractions, which is the conversion service and the message converters, right? So, and we'll get to that, more of that in a few minutes, right? Let me, so what else I can do with this, okay? So, all right, so I invoke this function. This function, this function is obviously an imperative function. And, a lot of the talk right now is about reactive programming, reactive functions, right? So, and as we'll see in the future, sometimes it could be a matter of preference, or sometimes it could be a matter of sort of limitations, or a matter of something that is required by your organization. So you, like in other words, can you invoke this function in a reactive way if this function is written in an imperative way? So let's try it, right? So I'm going to do function apply, and I'm going to pass, instead of just a value, I'm going to pass flux, just A, B, C. And after that, so I can either cast it to, or I can just simply add type information here. I'm going to call it flux flux. So I'll summarize in a second, and then subscribe. And here I'm going to do system.out print line. Print line. If I could only learn how to type. All right, here we go. And here we go. So so let's summarize quickly what happened before we move on any further. So what you have just observed is that while I have a single function which is written in an imperative way, which takes string as an input parameter and produces a string as an output parameter, this function actually could be invoked pretty much any way you want to, right? It could be invoked in the reactive. It could be invoked in a imperative way. It could be invoked with a different type information, and still we'll do our best to do whatever it is necessary to do necessary adaptation, to do necessary conversion, to do necessary anything to make sure that this function is invoked. Okay, so I'll show you in a few minutes. I'll show you more interesting reactive cases with imperative functions, but let's move on. So so you've seen type conversion, you've seen reactive versus imperative. Let's stop a little. Let's talk a little more about type conversion. Okay, so I have this one function right here, which is function that basically reverses what? Reverses a person, right? So I have a Pojo class here, person, which is pre-written, again, just to save time. I couldn't make it simpler, just a Pojo class, kind of a domain class with a single attribute name. And that's it. So we're going to be calling this a reverse function. So let's kind of forget all this for now. Let's just go back to the typeless way of doing things, even though we can define, any kind of type, right? So the function is going to be reverse, right? And we're going to say a function that apply, and we're going to say Oleg, right? So let's print it. Okay, and let's invoke this function and see what happens, right? So obviously it could not convert the input because this is really, I'm not passing something that is convertible to a Pojo. But I can do this, right? Let me make it something like name. I always have a hard time with this. Name. Okay, so now it's supposed to work just fine, right? And it reversed my name, right? So I passed the string, but in this case, I'm passing a JSON string. And as you may have guessed, we provide by default sort of a JSON message conversion strategy that will recognize that this is a JSON, this is a Pojo. I can convert one to another, and everything works, and you didn't have to do anything for it. But let's switch it back to how it was before and say, listen, there are cases when, okay, it's neither JSON, neither this, neither that, and I need to be able to somehow convert the type of data that I'm sending to the type of function signature that I have, right? Especially in the case of legacy functions where you may not be able to change a lot of things, right? Where you'll be able to maybe introduce some extension point to the framework like Spring Cloud function, but you cannot change the source function because remember, those things could actually come as already legacy jar files where this functionality is already written, okay? So what can I do? So again, let's just make sure it fails so we can see, bring everything back to the failing state and move on with that. So as I already mentioned earlier, in Spring, we have two strategies. We have conversion service and we have a message converter. So in this case, when you are invoking a function, we kind of use either one of those strategy. And in this case, what we're going to do is we're going to use the message converter. Again, I pre-written one, right? It's just a standard Spring message converter implementation. So this is core Spring messaging. So I'm simply creating a new implementation where I'm going to say, listen, take this string, pass it as a name, and create a person. That's all it is. And again, all this code is going to be available as soon as this presentation is over. I'm going to push it. And some of it is already there, but some of it is not. So I'll push it as soon as I finish. Okay. So now I enable it. So it's a bean, right? So it's going to be registered. And somehow, well, not somehow, the Spring Cloud function is going to pick it up, is going to add it to the stack of message converters. Just so you understand, there is a stack of several message converters, and this is going to be just another one on top of the stack. That's going to be, and a framework will delegate to those converters to do whatever needs to be done, right? So, now we're going to execute it again, and everything worked just fine. So again, to summarize, we have an opinion. In order to enforce this opinion, we provide you with enough abstractions and enough implementations, pre-configured, enough configurations to enable you to do certain things within a particular opinion. However, if that doesn't suit your need, we also provide you with a way, within a typical boot fashion, we provide you with a way to extend the framework itself to fit the goals of what you're trying to accomplish. All right, let me quickly check my notes just to make sure. All right. Now we're getting to the cool part. So before we get to the so function composition. So again, you're going to say, well, like, why are you talking about function composition like it's a big deal when function composition is actually a feature of Java functions? For example, function and then I can do another function and then another function. That effectively becomes a function composition because the result of this will be a single function that is a composition of two functions and so on and so forth, right? That is true. However, there's quite a few limitations with that. First of all, in order for this code to work, right, the function on the left and the function on the right has to be type composable, right? So which means that I cannot compose uppercase with reverse, right? Why? Because uppercase outputs the string, meanwhile, reverse inputs the person, right? So I cannot do it in a conventional way, right? However, Spring Cloud function will have absolutely no problem doing it. But how do we specify function composition using Spring Cloud function? Well, simple pipe, right? And all of a sudden, you still got a single function, but that function is a result of a composition of two functions, right? In this case, functions are typing composable. However, there should be no problem for them to work. All right. Oh, anybody see what I did or what I didn't do? But still, it's kind of cool. I've reversed and then effectively unreversed myself, right? So and basically composed two of the same functions into one. Anyway, but here's what I really wanted to do. So uppercase and reverse, right? The point is that two functions were composed, right? Well, how far can I push the limits of this? Well, let's see something. I have another function here, which is literally a replica of the previous function, which is reverse. In this case, it's just a reverse reactive, right? So now I have two problems. Not only do I have incomposable input types versus output types, I also have functions on a different style. One is reactive, one is imperative. So what can I do? I can still invoke it just fine. So let's go back to that previous way, saying function apply flux that just Okay. And as you can see, everything is working. Again, just to summarize, we've composed two functions. Oh, reverse. I didn't show you the cool part. So just to summarize, we have two functions within composable types, within composable programming styles, yet we were able to compose them and invoke them and deal with them. So that kind of shows you some of the interesting capabilities of Spring Cloud functions. So again, I'm referring to my demo notes to see if I'm missing something. Oh, Pojo function, right? So now, since we're on this thing, I'm going to do one other thing. So I have another function here, which is not really a function. So I have a class, Pojo uppercase, right? So as you can see, it doesn't implement a function. It's just literally a classic Pojo with a single method, uppercase me, not even apply or anything else. So it's literally just a Pojo function. So, and I have a bin here. So Pojo uppercase, right? And so I will do like this, and results should be the same. Okay, so again, so hopefully right now you will see some of the values that provided by the core Spring Cloud function. Now, just to finalize this portion of the presentation, okay, just to finalize this portion of the presentation, what I wanted to kind of, again, tell you is that while I'm casting this function to just a raw function, and I can put any type parameters, because we are taking sort of a typeless, and we interrogated some initialization time as well as the runtime to see and adjust the type of input you're sending to the actual style of the function. And the class that is responsible for that is actually function invocation wrapper, right? So you can cast it to this, and that's exactly what you're going to get back, and everything is fine, right? So, but this is really where if you're one of those who wants to go into the code and investigate how things work, then break it apart, reassemble it, and so on and so forth. Function catalog is just a strategy. There is a simple function registry and being factory aware function registry implementation, but you can easily determine that by simply with your IDE, and function invocation wrapper is actually what represents your function, a kind of a wrapper over your function, where the type conversion, where this adaptation between reactive and non-reactive, and many other things are happening. So this is the part where I would typically say, are there any questions? Unfortunately, we're in this virtual world, and if I break into the Slack, I probably will never come back because I'll be answering questions. I hope there are questions. So what I'm going to do instead, I am going to go back to the slides. Okay, and finally, we are at the portion of the presentation, which we kind of, I hope you're all sort of waiting for, where we're going to talk about the real important parts, the parts that you really, that's in a sort of a title of the presentation. And that is, of course, the ice cream, right? So yeah, that's not true, but ice cream is a great analogy to what I'm about to share with you. So so here's the story of two ice creams. So on the left, you have a plain strawberry ice cream. On the right, you have that same ice cream properly served, properly decorated, obviously something that you would prefer something on the right rather than something on the left. Understandable, right? But what this demonstrates is that if you look at the ice cream, it sits somewhere in a big jar. It's the same no matter what. But depending on how you decorate, depending on how you serve it, things may change. Whether it going to cost more, whether it's going to taste better, whether you're going to think it tastes better, but it still tastes the same. It doesn't really matter. It's just that we are decorating this particular ice cream with additional behavior. And with functions, we can do the same thing. Remember earlier I mentioned that the code that I was just writing, you would never really have to write unless you're an integrator. Well, as an integrator, as the person who turned this into that, you would need to understand the code that I've just written. But as a consumer, you just need to be able to know what you are ordering and how to properly order it, right? So going back to this, so functions is effectively like a raw material. So it provides implementation of the functional aspects of your requirements. It doesn't know how it is going to be invoked and where does the output of this function should end up, right? It only knows that I need to be able to debit or credit or issue a citation or do something, right? That's all. And once it's done, it produces the output and it has absolutely no knowledge of neither where the input came from or where the output will go. And that's how we want to keep it, right? But with Spring Boot and what Spring Boot actually gives us, the concept of auto configuration, we can effectively start managing or build our applications by simply managing its dependencies, because dependencies right now are not just a jar file with a bunch of classes that we can utilize. Dependencies right now provide you a bunch of classes we can use, as well as the opinion on how they should be used. And that opinion is expressed in auto configuration. So now I'll show you in a few minutes. I can just simply add one POM entry into my POM file, and my functions that we just saw, they will quickly become a REST endpoint, right? And you can start interacting with them via REST without doing anything to your code, nothing at all, just a POM file. Or, as you'll see today, and you'll see more tomorrow, you'll be able to turn this function into communicate with this function via RSocket, and not just one single method, multiple operations provided by RSocket, right? So we'll do adaptation. In other words, just like I was doing today, this actually kind of should, for those of you who are familiar with, even a little bit familiar with RSocket, which provides 5 different operations to interact with the other end, so to speak, right? So you can actually, some of it is like request response, which is one-to-one versus request stream, which gives you kind of a streaming-based operation, right? So again, with what we've done, like as an integrators, we're not requiring you to write a function in a specific style. All we're requiring you is to write a function. We don't care how you write it. The framework, the integration that we provided, will adapt your request to that function. Maybe you want to deploy this function on a serverless platform. You can do that as well. Or as you've seen from Mark Heckler, maybe you want to make it a whole-blown messaging app where you have, a messaging system on feeding the function and another messaging system or the same messaging system consuming the output of that function, right? So again, as you can see, the point of this sort of quick slides is that nothing changes in the middle. The only thing that is changing is the world around it, right? So at the end of the day, basically, the ice cream is still strawberry, the function is still uppercase, and the only thing that changes is the world around it. So we have 15 minutes, which is more than enough to go through the rest of the demo. So back to the demos. So as I said, we don't need this code anymore. So I'm going to take actually in function invocation wrapper. I was about to delete this, but what I'm going to do is I'm going to simply, well, fix it. So actually, tired to understand why it's not working. So I'll just do function invocation wrapper and leave it as a comment. So what I'm going to do is I'm just going to comment this code out. So you'll be able to, obviously this presentation is recorded, so you'll be able to review it. But I'll leave this code there. So for those of you who are going to have it fresh in their memory, they can just play with that. And what I'm going to do is just leave this portion of it, right? As you can see, I don't even need to have access to the application context, right? So at this point of time, if I try to start this application, it will just exit without anything happening, right? Because I'm not doing anything, right? However, what I'm going to do now is I'm going to go into the POM file and I'm going to enable this dependency. So Spring Boot Starter Web and Spring Cloud Function Web, right? So let me start this again. And all of a sudden, the application is going to be live, right? So it's not exiting, it's running. So we started the web server. So now let's go here and localhost uppercase Oleg. And all of a sudden, my function became a REST endpoint, right? Oops. All of a sudden, my function became a REST endpoint. Do I want to compose it with something? Sure, I can compose it. Type reverse, and all of a sudden it reversed, right? So I can still do the same operations. I can still access any function that is available. Let's do that Pojo one. What is it called? I forget. Pojo uppercase, right? So we're gonna do Pojo uppercase. It's still uppercasing the string. So everything working, and I didn't have to do anything. As you can see, the only thing I really needed to do is throw a couple of dependencies, and all of a sudden my function or functions in this particular case became a REST endpoint, right? So, okay, now we're going to get to the sort of a stream part, something that Mark Heckler was presenting. So what I'm going to do for this is kind of talk a little bit more about some of the internals as well as Spring Cloud Stream. So I'm going to comment all these other functions. And we don't need them anymore, actually, not for this thing. So we only have one function, uppercase. So all of a sudden, I'm gonna go back to my POM file, and come on. There's just this Zoom things on top, and I kind of covers the anyway. So this particular case, I'm going to use Spring Cloud Stream. I'm going to use Rabbit as a binder. Rabbit as a messaging system. And because I'm going to use Rabbit as a messaging system, I'm going to use Rabbit binder. Okay. So by bringing Rabbit binder, again, one of those things like bringing Rabbit binder brings entire Spring Cloud Stream, and by bringing Spring Cloud Stream, it's going to bring Spring Cloud functions. So technically, none of this is necessary because this one dependency will bring everything else transitively. So let's go back here, and now I'm going to go into, well, first of all, I'm going to start the application. Well, actually, no. First, I'm going to go straight into the Rabbit console. As you can see, I cleaned it up. There's no queues. There's no changes. All this stuff is just Rabbit defaults. So I'm going to start the application, and all of a sudden, come on. All right. So hopefully everything is working. So how do we know? Oh, we know because all of a sudden our exchanges and queues were already pre-created for us. So now I can say, hello, Spring One. And all of a sudden, hello, Spring One. And the function was invoked and the message went out to the output destination. Oh, that's very cool, right? So all of a sudden, again, by bringing just the dependency, this application all of a sudden became a streaming application. But what about our REST endpoint? Well, that's still working. Actually, no, it's not. Oh, giving you a second to think why it's not working. That is because I canceled everything. I commented all these functions, so we only have one function. So let's just simply do the uppercase, and we're back to it's working, right? So all of a sudden, if I comment these entries, it will be just a stream application. But right now, because we have this and that, it became stream and resting points. So again, I'm basically creating the nature of my application by simply throwing certain dependencies on top of it, right? But let's hold up here for just a little more. So I'm going to enable another function. I'm going to go back with my reverse, right? I'm going to kill the application. And I'm going to go also to Rabbit console and just to clean this slate, I'm going to delete everything. And here is nothing. Okay. So I'm going to start the application again. There's one fundamental property that you most definitely will be using, and I have not used it yet because I really didn't need to use it, but now it will be necessary. As you can see, application started successfully. However, there is nothing here. There's nothing here. So it's almost like what happened, right? So in order to understand what happened, let's look at the logs and specifically the statement that follows right after lookup function. First of all, it's looking up function with no name. Basically, it's attempting to find the default function. And it can find it, and there's a message that explains to you why it can find it, because it says found more than one function, bin and bin factory. It sees uppercase, it sees reverse. If you did not intend, disregard, but if you did, use Spring Cloud function definition property, because we don't know which function you want to use, right? And this is where we're going to use additional properties. So I can do it in the property files, or I can, again, make it more demo friendly and do it all in one screen. Spring Cloud function dot definition equals come on, uppercase. This window, this Zoom has to do a better job on. Okay. All right. So let's start it again. All of a sudden, we have the same uppercase, and we can post something and everything works, right? So, but what if I want, so again, on the Spring Cloud stream, staying on this topic. So basically what I did here is by using this property, I resolved a tie. Now, remember the composition, right? That's exactly where I would specify that, right? And again, this property is going to be translated into, the value of this property is going to be translated into this lookup method that you have seen me use earlier. So all of a sudden I go back to Exchange, I have uppercase reverse, right? All of a sudden I have new destinations, and you can also see what the naming schema is. We're basically going to concatenate that. And again, if it was a stream talk, there is a way, because obviously you can see how quickly, if you compose 5, 6 different functions, how quickly this could become very inconvenient name, right? So we have a way, which is a property called Spring Cloud Stream Function Bindings, and then you would use this name and you could map it to something else. It's actually very well documented in our docs. So you can actually map it to a more useful name with that property. But the point is that we created the binding, and we can again, and it's uppercasing, and something happened. Oh. Well, first of all, what you saw is retry, and then you saw the conversion error. Why? Because, well, we're trying to reverse the person, but we commented this message converter, right? So let's re-enable it and do it again. Allow when this error happens, but you quickly see how you can fix them, right? So hopefully you understand what happened is that our reverse function takes the person, our uppercase function outputs the string. So we're attempting to convert plain string, which is not really a JSON string representing a person. So all I did is register the converter. So now I can go back in here and say, hello, people. How about I'll use lowercase? Hello, people. And all of a sudden we got reversing hello people. So person, hello people, doesn't really matter. The fact is that the conversion happened the same way I was showing you to you before. So hopefully this will give you a good preview as to how this thing works, how the code that I showed you before is becoming, so now hopefully you understand why this works. And that is uh, because of understanding how this works, right? So moving on, we have 5 minutes. Um, Lambda, right? So obviously, I'll show you in the project. We have function sample AWS. This is exactly the sample, and if I open it, um, you can see that this example contains literally just a Spring Boot application with a single function called uppercase, right? And just for the sake of saving time, I already deployed it. So I'm going to go here. It's the same uppercase function. I'm going to invoke it with a hello test string. And um, function was invoked, everything works, right? So it's the same function. Obviously, it's almost like the details are in the palm. It's like the details are the devil's in the details, and the devil's in the palm. So in this palm, we basically have a lot of the Amazon AWS properties, their dependency, their plugin, that will generate the proper jar, and so on and so forth, right? So what else do we have? 4 minutes left. Let me just go back to the slides. So our socket. You know what? I'll skip the our socket for reasons being because I'm going to rush, as opposed to Spencer and I. I'm going to have a whole hour to talk to you about our socket tomorrow, and it's a morning presentation, so hopefully it's a much more convenient time for everybody. So 3 minutes left, and quick summary. So functions are simple, expressive, extensible, and portable, right? You can see that you literally write simple functions, and we're able to do all kinds of different things with them. And what you saw today was just sort of the beginning. There's, like I said, there's a function deployment, there's a function array, there's a lot of extra features that I haven't had a chance to show you today. Most, if not all, requirements could be expressed with functions. So this is probably, if I say the most valuable outcome that you should take out of this is this particular bullet point. I'm going to pose to you a question, and unfortunately, I cannot gauge your reaction, but think of a requirement, past, current, or future, that you cannot map. Any requirement, I'm going to be blunt, any requirement, past, current, or future, that you cannot map to function or functions, either supplier, function, or consumer. We are having this debate all the time. So far, we could not come up with any, and I'm almost like challenging you to challenge me to come up with a requirement that could not be addressed with either function, supplier, or consumer, right? And but if I am if I'm correct, and if this is true that anything could be addressed with functions, supplier, function, or consumer, then you obviously see where it could end up, because you're going to be writing function suppliers or consumers, and then simply writing once, kind of like one, yes, you're going to write maybe additional integration framework, but once it's written, it's done. Because now any function, any supplier, any consumer will be able to integrate with you. And hopefully that framework is Spring Cloud Function. Okay. We always say, pull requests are always welcome. Testing. Obviously, testing a functional application becomes very simple, because if you entrust everything else to the framework, then the only thing you have to test is the functionality, which is basically write a simple unit test case that tests your function, not how it is being interacted with another platform. So the list of benefits is kind of endless. And hopefully we can have debates on and ideas, have debates and exchange ideas in the future on this and other topics. But right now, thank you. Enjoy your ice cream, enjoy your functions, and hopefully this is the first and the last time we're doing it virtually. And next year, we'll hope to see you all live and in person. Thank you very much.
All right, Oleg, thank you so much. I appreciate it very much. I forgot you're in France. I've been watching some of the tour and it just reminded how gorgeous the French countryside is. And it reminded me that my wife and son joined me on a trip to Paris last year, and we had a more than just fleeting conversation about would we maybe move to France. So I'm delighted to remind myself that you're there. Now, if you looked at Spring One and said the only thing that would make Spring One better would be more Oleg, guess what? We have more Oleg for you tomorrow. He'll be presenting with the one only Spencer Gibb. So that I believe you guys are leading off my track tomorrow. So I'm very excited about that with some more function goodness. Awesome, fantastic. But in the meantime, we're going to take a quick break. Get yourself some more beverages, stretch your legs, hit the restroom, and we'll come back in a few minutes with a bevy of our friends from Amazon.